Hi, we are team number 31. We are developing a game called Minions vs Aliens using JMonkey 3. This is our first week task board. For sprint 1, we see total effort estimate of 200 hours to be completed in 4 weeks at 50 hours per week. Week 1 task board shows proper 50 hours being burned down by the team, but in week 2, we see a fall in the progress by 16 hours. Again, in week 3, we see only 37 hours of work being done, creating a significant lag of 29 hours. So, during the week 3 team meeting, we discussed the resolution for all the blockers and motivated team to finish all the tasks. So, in week 4, we can see 79 hours of work being done, hence finishing the sprint part. This burn down chart aptly represents the work done by the team as the red line plotted against the ideal burn down, that is the blue line. Now let's hear in detail about the knowledge acquisition stories from each team member.
Hi, this is Krishna Bhanushali here, and my task for Sprint 1 were character modeling using Blender and geomap mapping using TerraMonkey. So, as part of the first task for my Sprint 1, that is creating a model using Blender, I have created this Minion, which is going to be our main character for the game. I had a lot of time wasted in identifying how to use a trackpad, but did not work. And finally, I got this. Oh no, this as a solution to work on models. So I never use trackpads. We then imported this model to the JMonkey platform using the import model fee function here, and it automatically converted the .blend file to a .j30 file for us. So the second part of the sprint was geomap mapping using TerraMonkey. So geomap mapping is basically changing the level of details of an element in the map based on how close or far it is from the camera. So as you can see, the elements that are very close to the camera, they have a thicker mesh, and the ones that are away from the camera have a very sparsely populated mesh of triangles. So a quick demo. This is basically the map that we have created. I will turn this into wire mode so that we can look at the details correctly. See, as we zoom out or move away, you can see the different patches appearing and disappearing. So this is how the geomap mapping works.
Hi, my name is Rahil Patni and I was focusing on the animation and special effects part. By reading various tutorials and going through demos, I learned many things. I've experimented on animation and effects. I've also prepared one demo. The demo shows particle emitter. It shows particle emitter. I have loaded a texture over here. One texture is of flame and another texture is of red color. We can see over here the particles are getting emitted. The particles over here are getting emitted in 3x4 texture animation. As per our need, we can set the texture animation we want. Also, we can limit the number of particles which are being emitted. Also, I have used two kind of colors, one which is the starting color, which is the yellow, and one is the end color, which is the red. This kinds of animation brings an interesting part in our game. So we will be using various kind of animations and special effects in our actual game, which we will be developing in Sprint 2.
Hi guys, my name is Utsav Popli and on behalf of Team 31, my task is to rotate, scale and move the object, apply the texturing to the material and take the input from the user. To do so, I have a very simple code written in Java using the JMonkey engine. So here's my code and I'm using the unshaded.j3md file to apply the texturing to the material. I'm also using the keys from the keyboard to move the objects around in the 3D world space. So for right now, let's see what's happening. So as you can see, the cubes are not moving. Let's just move the cube using my keyboard. Left, right, up and down. Also, what if I just want to move the cube in the 3D space continuously? So here's my simple update function. So now the cubes are continuously moving in the space, but I can change the location of the cube, and I can also change the color of the cube randomly. So see, here you go. I'm pressing my S key and it just changes the cube of the color. That's all from my side. Thank you.
Hi, this is Ashish. In Sprint 1, I have explored physics component of the JMonkey engine. So I'll be briefly talking about the physics engine. Physics is an integral part of any gaming IDE. It is required in a game to enable objects to follow laws of physics. JME3 has built-in support for JBullet physics. It is bundled in com.jme3.bullet package. Physics space is one of the central objects of physics engine. We have to add all the objects to physics space to make them physics enabled. For a physics simulation, by default, one length unit is 1 meter, one weight unit is 1 kg, and it runs internally at 60 fps. Now we'll see a short demo of an experiment that I have implemented. In this code, we can see that the physics binding is achieved by a bullet abstract object and all the spatials are attached to this object. Now we'll just run this code and see the demo. So we can see the grass terrain surrounded by the sky. Also we see a brick wall and the crosshair which represents the cannon's focus. So as we start hitting the gumballs, we can see the brick wall fall, which shows us the dynamics of collision and gravity on the bricks and the gumballs. This explains the use of physics engine in the game.
Hi, I'm Kalpana Roy and I'm responsible for the development of GUI of our project. In order to do so, I explored many UI related features of JMonkey during Sprint 1. After going through various online tutorials and online book shared by Professor Paul, I narrowed down the following features that we would be using for developing our GUI. Now let me give you a brief description of all these features one by one. Let's start with the scene. Scene adds a new layer to your UI, and Scene Composer allows you to edit scenes stored in J3O files. You can add light, effects, models, etc. to your scene. So, in a nutshell, we can say that scene is the basic building block for any game in JMonkey. In this screenshot of my demo project, I have added a scene on top of which I have created this landscape. Now let's move on to our next feature, which is Spatial. Spatial is an element of 3D scene graph. Scene graph is a data structure that manages all objects in your 3D world. So when we add a spatial to a scene, it means that we are adding a child node to the root node or the parent node. Once a node is added to the 3D scene graph, we can create different structures by generating, painting, and editing the terrain. For example, in my demo project, I have added mountains by raising the terrains and lake by depressing the terrains. After you are done with the editing of terrain, you need to add different textures to it in order to make it look like real world landscape. For this purpose, you can use existing textures or download free tileable textures from the internet. For example, I have used grass texture for my fields and mountains and water texture for my lake. In order to make all these editing and changes visible, you need to add light to it. You can use any light from light and shadow palette as per your requirement. I have used ambient light and sunlight in my demo project, which gives me feel of a bright sunny day, right?
The following are the outcome of Sprint 1. We'll be using the following, that is modeling the characters of the game. We'll be animating and associating it with the game story. Then we'll be taking user inputs and implementing the physics engine for collision dynamics and shooting. And finally, there'll be work on GUI, which involves maps, terrains, light, and lighting effects.